When designing circuits, we often place a resistor in series with a signal line. Typical values are 0 ohm, 22 ohm, or 33 ohm. It may be placed at the signal source or at the receiver. Today I'll explain the purpose of adding a series resistor to a signal line. The first purpose is impedance matching to reduce signal reflections. As we know, light reflects when passing between different mediums. Electrical signals behave the same way. High frequency or fast edge signals reflect when they hit impedance changes. For example, a signal travels from the driver through PCB traces to the receiver. The driver usually has an output impedance of 17-40 ohms. Single-ended PCB traces are typically designed for 50 ohms. The receiver, often CMOS, has very high input impedance. So reflections occur when the signal enters the receiver. The reflected signal adds back onto the original signal. This causes multiple reflections at the receiver end. In practice, reflections appear as overshoot, undershoot, or ringing. For example, in one of my 25 MHz projects with 0 ohm resistor, the overshoot was very obvious. When I added a 33 ohm resistor, the overshoot dropped significantly, but the resistor cannot be too large or it distorts the waveform. Comparing 33 ohms with 1000 ohms, the waveforms are very different. For impedance matching, the resistor must be placed at the source. Values under 100 ohms are used for high-speed signals. The second purpose is absorbing noise and interference. Long traces or nearby fast signals can couple narrow spikes onto the line. If the receiver triggers on edges, these glitches can cause false triggering. Adding a resistor at the receiver helps absorb these spikes. Glitches may have similar amplitude but much lower energy. After passing through the resistor, they get attenuated. This method works well for low-speed signals. The resistor is placed close to the receiver. Values can be in the kilo-ohm range depending on the design. Reset pins commonly use series resistors for noise immunity. The third purpose is for debugging and measurement. With dense pins or BGA packages, you can't probe the signal directly. So experienced engineers at 0 ohm resistor in series. This makes probing and debugging much easier. That's all for today. Thanks for watching.